Okay. I'm very glad to be here in the 55th Congress of HVAC in Belgrade, representing the research and development team of MIDEA in Stuttgart. I'm going to give you some details about the MIDEA's energy management and energy storage system called Helios. Maybe some of you know it already. Then we'll see one small application in the case of room air conditioners. So to have a basic idea, this is a standard residential installation. We have the photovoltaic panels, we have the batteries and the inverter, of course, and a typical consumption would be the air conditioner. Of course, we have also lights, kitchen, etc. The product we are going to discuss is called Helios, and it's energy management and energy storage system. I have two basic models. One is the one-phase and three-phase. This product is designed, developed, and produced by MIDEA. This is important because usually most of these products are third-party made. So only the batteries, of course, are not made by MIDEA because there are only 3 factories in the world that make. So it's a very simple product in terms of installation. It belongs in the general family of smart products. It's connected through Wi-Fi and Modbus, etc. So it can provide storage from the photovoltaic, and also it can manage all the consumptions in one residence. I will show you some scenarios to understand better what is happening. And this is a typical connection. We have the panels, we have the batteries and the inverter. Of course, usually we are connected to the grid, and here are some basic consumptions, heat pumps or air conditioners, whatever, production of domestic hot water, which is gaining a lot of market share, and even EV charger for electric cars. So, as I told you, I will give you, I think it's 4 scenarios for the operation. The most common installation is the self-consumption, which means all the energy from the photovoltaics is being fed to the consumptions in the house. So early in the morning, we don't have so much power. We use partly the grid and partly the photovoltaics. As the day moves on, we have more power from the photovoltaics, so we can keep the surplus to the batteries. And in the evening and at night, when we don't have so much solar power, we can use the battery that is charged and, of course, the grid. The second most common scenario is the feed-in mode, which means we have more power because we have big photovoltaic installation, usually more than 10 kilowatts, so we can sell or divert to the grid. Again, early in the morning we have low production from the photovoltaics, so we keep to our consumptions. Later through the day we have more power from the photovoltaics, so we cover our consumptions and we sell to the grid. And if there is still a surplus, we can store to the battery. And of course, as we go to the night, we keep the batteries and partially also from the grid. As I said in the beginning, this is an energy storage product, but also an energy management. The next 2 scenarios are actually what is more interesting, since we are going to see what is happening with the energy management. In some countries, as Belgium and Italy, there has been a so-called capacity tariff, which means that the government and the local electricity distributors are trying to control the maximum capacity of the residences, of the residential consumptions. So if at one point the consumption in the house gets above a certain limit that is given by the grid, and if that happens for, let's say, more than 15 minutes, at the end of the month, the whole consumption of the house will be calculated at the highest level, and not gradually as it would be what is usually happening in most cases. So when we have this energy management system, this calculates and monitors at each point what is the consumption of the house. So if it goes to go above the limit, then gives priority to the battery, so that at no point we exceed towards the grid the limit that has been set. So this, of course, helps at the end of the month the bill to be as low as possible. And another interesting use is, if you see here, there is even no photovoltaic. In most of the countries, the price of the electricity is not stable through the day. So, for example, if at night the electricity is cheaper, we can charge the batteries, and during the day, when the tariff is higher, we can use the batteries instead of the grid. So this gives a very good efficiency in the total consumption of the residents. Okay, as we saw also in the beginning, in a house we have so many consumptions, lights, kitchen, but the greatest part is usually heating and cooling. So we're going to see how this energy management system can operate and how the user actually can benefit from a residential air conditioner. Actually, I'm going to show you the latest edition of MIDEA's room air conditioners. It's called Solstice, and at this point it's one of the most efficient units in the market. A few data here. I don't want to bore you with all the details. As you see, it's A++ in the cooling. The product is certified by the Eurovent, and in the warmer area, it's also A++ in the winter. In the average area, it's A++. As of course you know, this is a Congress of Engineers, so you know better that the laws of thermodynamics are given. We cannot do magic, we cannot do something different than everybody else does. We can change the refrigerant liquid or the refrigerant gas, and this is happening a lot lately. So if we cannot do so much at the refrigeration cycle, we can do other things to improve the performance and the efficiency of the products. So this air conditioner depends heavily on the EcoMaster. EcoMaster is an AI machine, artificial intelligence machine, that, as we see here, has a large database of temperatures in general of data from all over the world. So when someone uses it in Belgrade, it can use previous year's data. But more than that, it is a very strong learning machine. And I'm going to show you what this means. So this unit, each day, gathers all the data from the outdoor unit, the indoor unit, even the remote control has temperature sensors, so whenever it's moving in a certain room, it gathers data also in the geography of the room. So it is learning, and day by day its performance is getting more accurate, meaning that it can deliver the set point faster and with less fluctuation. Because as we see, this is actually what the problem is with the air conditioning. So actually we are going to have a more precise temperature setting. Imagine something like Google Maps. The more people use it, the more data the system is gathering, so it can predict and give the best route to get from point A to point B. So more or less it's something similar that is happening. The machine is learning from the user and can provide better comfort and efficiency, of course, in the end of the day. This is a more graphic, let's say, presentation of what I was telling you before. This is a traditional temperature control, and this is through the EcoMaster. You see that we have less fluctuations, we have faster delivery of the set point, and overall we have better efficiency and better comfort level for the user. And one last, let's say, innovation that also increases the performance of the unit is the anti-corrosion coating that is new for, at least for MIDEA, and helps even the heat dispersion by 15%. So this also increases the performance of the unit. That's all that I'm going to say. Just a small comment that this Congress has been for so many years. I believe that 55 years or how many years ago it has started, even the products were completely different and the engineers were completely different. So if we want, let's say, in the next 50 years, this Congress to be still running in an environment friendly to people, now it's the time to promote the efficiency, especially in the residential buildings. I come from Thessaloniki, Greece. I believe that most of the Balkans is almost the same. Residential buildings have a lot to improve in order to, in terms of efficiency and energy consumption. That's all from me.
For residential apartments.
Yes.
As you know, I mean, in Greece, one average size of residence is 120 square meters, the size of one apartment. Using photovoltaic panels on the top of one apartment like that, we can cover all electricity demand of the house, for example, using heat pump A3 plus and using some other techniques saving energies. And the second part of the question is, when we have surplus energy, can we sell the surplus energy to the public grid?
Yes.
Thank you.
Okay. Can we go back to the presentation? Just because it's a slide that I passed quite quickly. I think, maybe, no, here. First of all, the first part of the question, if we can cover the whole consumption of the house, it depends, as you said, in the efficiency of the appliances. If we have LED lights, if we have new kitchen, electric kitchen, new, even now, washing machines use heat pump to heat the water and to dry the clothes. So if we have this kind of equipment, yes. On the other hand, you mentioned about the apartment, which is an issue because apartments usually cannot put photovoltaics. We are talking usually about a residence that will be by its own. You know, if you have a block of flats with 20 floors or 10 floors, whatever, usually you cannot cover that. So this actually depends on what you have inside. If you have latest technology and high efficiency products, along with a good energy management system, because also this plays a great part, I think that yes, it's possible. And on the other hand, what you asked about the grid, yes, if the photovoltaic panel is well designed and there is a surplus, and of course there is the proper legislation, I don't know what is happening in Serbia. In Greece, I think it is a situation. You can sell to the provider of the network. It is possible, but of course not throughout the day, because you have fluctuations in the consumptions, you have fluctuation in the sun. The sun is not all hours the same. So at one point, yes, you can sell to the grid.
More questions?
All questions come from Greece. Σας ξέρω.
Also a Hellenic chapter. I love this city, so we are almost half Serbians.
Okay.
In your model that you say you have your photovoltaics and you have a battery, let's say that the heat pump covers all the demands of the flat or the house, but not the photovoltaics, right? So can we add photovoltaics in the system? Increase the capacity of the photovoltaics? That's the first part of the question. And the second part is, how do you calculate the battery of the system, and whether you can increase the capacity of the battery to cover it for, if you have the details for 100% of what you generate to use it?
Yes, okay. Actually, this, I was wondering if I should include this, but I left it out because I was asked to keep it at 20 minutes. So for the first part, yes, of course, you can add photovoltaics depending on the installation. So there is no issue. I don't have, unfortunately, the table for this product, but I can say it now, and of course you will understand. This product, this is the one phase, and this is the three phase. No, it's the other way around. This is the one phase, and this is the three phase. This is modules. Every module is 5 kilowatt hours, so you can add and add until you reach the desired, the conditions that you need. Fortunately, I'm telling it a bit funny. Fortunately, this is not a consumer product. This is not something that someone can go in the practical and buy it. It needs a mechanical engineer or an electrical engineer to make the study, to calculate all the consumptions, to see what kind of photovoltaic can be installed, and then to choose the battery, the correct battery for this installation. But the product is versatile because it consists of small modules, so you can build it up to your needs. Okay. So there is no other guy from Greece, so no other questions. Okay. Yes.
I see here there is your research and development.
Yes.
And I'm wondering, do you participate in development, in methodologies and research and standards? Do you track following?
Actually, it's the other way around, if I understand correctly. We are a team of 8 engineers based in Stuttgart, and actually we have geographical areas. I am responsible for the Balkans and Greece and Cyprus. And so we gather all the data from the market, I mean legislations or even subsidies, now that some subsidies are running in Greece for heat pumps, etc. And of course, information for the competition. And we gather this information in our R&D department, and then we make the request for the new products according to what is happening to the market. So we actually follow the, as you said, the legislations. We don't get involved in this. Okay.
There will be also standardization.
Yeah, of course, but we are quite new team. It's now second year, so.
Thank you very much.
Yes. Thank you for your time. Okay.